Okay. Yay. Okay. Awesome. I see everybody. Yay. I think I'm missing one. Let me just see if she's here. I think I might have missed her. No. Okay. Okay. So last thing we did is we added fractions that had the same denominator. Now we're going to add fractions that don't have the same denominator. So there's something we have to talk about, which was at the end of the last chapter, but I wanted to tie it together at the same time. I don't like doing common denominators and then not doing it right after. I like doing it right after. So let's talk about least common denominator. This is really at the end of 4-4. I'll put 4-4, and I'm going to put /4-5 because I tied it together. So let's say I want to add these fractions. I'm going to start not too bad ones. 5/6. Whoops. And 3/8. Well, in fractions, we cannot add or subtract fractions, cannot add or subtract fractions unless the denominators are the same. They have to be the same. This is not for multiplying or dividing because they don't have to be for adding and subtracting. So how would I add 5, 6, and 3/8? They're not the same. I have to find what we call a common denominator, and we call it the least common denominator because we try to find the first number that they have in common. I'll tell you what it means in a second, so we can make it a denominator. So when I do least common denominators, there's two ways to do it, but I think the easiest way, and I'm going to start here, 6 and 8, that's my denominators. And honestly, the more you do these, the better you get at them, and you don't even have to do this. But we'll start looking at multiples. So 6 is 6, 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30. So I'm just going to start with a few. What we're looking for is the first one that they share. Let's say 8, 16, 24, and I'm just going to stop. Then we just find the least common denominator, 24. The first number when doing the multiples that they share in common. So my least common denominator is 24. So let's look at a problem. So here it is. I want to add 5, 6 plus 3/8. I have to have the same denominator. So what I like to do is I know it's 24. I'm going to start rewriting it with 24 as a denominator. Well, how do you do that? Well, what number do I have to multiply 6 by to get 24? 6 times 4 is 24. Whatever I multiply the denominator by, I have to multiply the numerator by. So my new fraction, instead of 5, 6, I'm going to have 20 over 24. Why? Because I had to get the same denominator. If you are not sure about that as well, when you do multiples, you'll see that 1, 2, 3, the fourth one was 24. That's what you multiply by 4. Now 8 times y is 24. 8 times 3 is 24, which means to get 24, I have to multiply the numerator also by 24, or it's not the same fraction. You have to, whatever you do to the denominator, you do the numerator. That makes 9. Now I can add them. I add across and I keep the denominator. So 24 stays. I'm going to add 20 plus 9 is 29. And then according to the directions, because my math lab will say, write it as an improper fraction, which that's the answer. It might say, write it as a mixed number. So if I write it as a mixed number, 24, how many 24s and 29? 1, 24s and 29. How many are left over? That would be 5. 1 and 5 over 24. So either, depending on what the question asked you for, you would either enter 29 over 24 or 1 and 5 over 24. Really pay attention to what they ask because they like to go back and forth to every question. Hey, questions on our first one. No? Okay, let's do another one. That was our examples. Let's do some problems. Okay, so practice, we'll call practice. Okay, we're going to add 3/7 plus, let me move this up, 3/7 plus 5 over 14. Now, most of the time, you don't have to list the multiples because 7 and 14, they're just like 7 times 2, right? So I'm going to put, I know the common denominator is 14. Why? Because I already have 14 here, and I can just multiply this by 2 and I can get 14. So let me just put this here. Okay, so 7, this is what I need. This is what I have. What do I got to do? I have to multiply it by 2. A common denominator always have to do with multiplying. 7 times 2 is 14. That means I had to multiply the numerator by 2 to keep it the same fraction, just an equivalent fraction. That becomes 6. Now, if I compare these, that's already 14. I need 14, I have 14. So that means I had to do nothing but put 5 on top. That didn't change at all. And now we're going to add across. 6 plus 5 is 11. And 14 stays 14. And I should mention, I didn't have to do this time. I don't have to do this time either. Always simplify your answer. I don't have any way to just nothing. This is simplified. But if I could divide it to simplify it, you have to simplify it. All right, let's try another one. 2. Now I'm going to throw some X's in there because you need to know how to do it with X, but don't let it bother you. It just looks different. I'll show you what to do with them. I'm not quite sure what this one's going to be, so I'm going to list the multiples. So 15 times 2 is 30. Then if I add 15, that's 45. And if I add 15, I get 60. And then it's going to stop because now I just match 60, 60, and 60. So common denominator is 60. And this was subtracting, doesn't change anything. We still do it the same way. This is what I need for this fraction. This is what I have. It's exactly what I need. So I don't have to do anything in that fraction. I just write negative 17x. With this fraction, I have to change. I need 60. I have 15. What do I have to multiply by? Well, we can look here. 1, 2, 3, 4. 15 times 4 would be 60, which means I have to multiply this numerator by 4. So 60 is perfect. Now, what's 2x times 4? That would be 4. Whoops, let me put it in black. That would be 4x. Multiply 4 times 2, and the x just stays. Oh, sorry, not 4x. I said 4x. See, mine's not thinking today. Okay, 4 times 2 is 8, 8x. Now, how do I put these together? We are just adding like terms. That's what we've been working on, right? So 60 is my denominator because the denominator stay the same. But let me write this down here. what is negative 17x minus 8x? Because that's what it says, negative 17x minus 8x. Well, one thing at a time, let's do our numbers. Negative 17 minus 8. Okay, so that's the same sign. So I add them and keep the sign. That's negative 25. And the x just stays negative 25x. But now look at my fraction. I have a 25, I have a 60. I know I can minimally divide them by 5 because they're multiples of 5. So we're going to take and we're going to divide them by 5. Both of them, whenever I do the numerator, I have to do the denominator. Well, not 2, 5. All right, so let's see what we have. If I divide by 5, 25 divided by 5 is 5. So it would be negative 5x. 60 divided by 5, that would be 15. Is it? 60 divided by 5. No, 12. 12. And that looks like simplified. So that's my answer. Now that problem had everything. We had to get common denominators. We had to work with x, combining like terms. Just remember, when you combine like terms, you just add or subtract what's the number in front and you keep the x. You don't change the variable. You don't change the variable. You don't change the exponent. You're just combining like terms, putting things that are the same together. And then we had to simplify the fraction. Question? We doing all right? And let's do some more. I'm going to start a new page. Let's do negative 1/5 plus 9/20. I'll bring a variable back next. Okay, so some of you are here looking and going, okay, I know the common denominator, and some of you aren't. So that's no big deal. So 5, 10, 15, 20, and then I can stop because that's what I want. I have 20. So my common denominator has to be 20. I want that to be 20, and I want that to be 20. So I want 20. I have 5. What do I multiply 5 by to get 20? I multiply it by 4. And whatever I do to my denominator, I have to do to my numerator. So negative 1 times 4 makes my new numerator of negative 4. I want 20. I have 20. I have nothing to do except write down my numerator, which is 9. It's not going to change because I already have what I want. And now that they're the same, we can add the numerator and keep the denominator. So negative 5 plus 9 is 5/20, but I can simplify that by dividing both of them by 5. And I will get 1/4. So if I add negative 1/5 and 9/20, I get an answer of 1/4 after I do all that work. Let's do another one with a variable just to get some practice in. Negative 5y over 6 plus 2y over 9. And hold on 1 second. There we go. Now we need to get common denominators. What could this be? Some of you know, some of you don't. So no big deal because we can write our multiples down. 6, 12, 18, 24, 30. I just did 6 6, 6, 6, keep adding 6. And then we have 9, 18, and then I'm going to stop because I just found my common denominator is 18. It's the first number that they share. So I know I want 18, and I want this one to be 18. By doing it this way, how I'm organizing it, it keeps the work sort of kind of organized, and you don't sort of kind of get lost in the problem. So write down the new fraction with 18 in the denominator, and then you're going to compare. I have 18. No, I need 18. I have 6. What do I do to 6 to get 18? By multiplying, I have to multiply by 3. But that means I have to multiply the numerator by 3. And then you can write the new fraction. Negative 5 times 3 is negative 15. And the y just stays y. So that's my new numerator. I call it a game. It's like the same game. Okay, this is what I need. This is what I have. What do I do with 9 to get 18 by multiplying? Well, I would multiply by 2. If I had to multiply the denominator by 2, I'm going to multiply the numerator by 2. And 2 times 2 is 4, and y stays y. And now I have like fractions that I can put together. When I put together with adding, the denominator stays the same. That's why we get the common denominators. That stays the same unless we can simplify. And then negative 15 plus 4. Okay, negative 15 plus 4, opposite signs. So I'm going to subtract them. 15 minus 4 is 11. But 15 is a bigger number, so it's going to be negative 11, negative 11y. And then I see, can I simplify anything? Can I divide 11 and 18 by the same number? And the answer is no. And that's my common denominator. All right, I'm gonna stop for questions. What I'm gonna do is I'm gonna put we only did numbers in our denominator. Now I want to add variables in our denominator. So how do we get the same denominator when we have variables? All right, so let's say I want to add the x is just going to stay, right? So x is going to stay, but I still have to get my numbers in the denominator to be the same. So I'm going to do my multiples: 9, 18, 27, 36, not that 5, 45. So I'm just doing 9 times 1 is 18, 9 times 2. Wow, 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27. I'm just doing the multiples. Then I have 12. 12 and 12 is 24, and 24 and 12 is 36. So I know my common denominator has to be 36. But because it has an x, it's 36x. The same idea, it's just that we have an x too. Now, this is what I need. This is what I have. I have my x, but I have 9. So what did I multiply? What do I have to multiply 9 by to get 36? I have to multiply it by 4. So whatever I do to my denominator, I have to do to my numerator. 8 times 5 is 32. That's my new fraction. 32 over 36. Same thing with the next fraction. This is what I need. This is what I have. I have my x, but I don't have 36. I have 12. So what do I multiply 12 by to get 36? 12, well, I can actually see it here. 12 times 1, 12 times 2, 12 times 3. So 3, 3. 9 times 3 is 27. Now I have common denominators. I fixed them. Now I can add them. So my denominator is going to stay 36x. That's why we get common denominators. So it stays the same. Now I'm going to add 32 and 27. So let me do it down here. 32 and 27. That's 9. That's 5. 59. Can I simplify that at all? Whoops, I'm trying to erase it. Can I simplify that at all? No, but I could write it as a mixed number. All right, so let's see. Which looks really weird with an X, by the way, but we can. Okay. How many 36s are in 59? Or you could take 59 and then divide it by 36. That'd be 1. How many are left over? I'm trying to show you different ways to do it. So 9 minus 6 is 3. 5 is 2. So it'd be 1 and 23 over 36x. Just like we did before, except the x is in the denominator. And again, you want to pay really close attention when you take your test and when you do your homework of what it's asking you to put in. Is it asking for an improper fraction? That's that answer. Is it asking for a mixed number? That's that answer. Okay, I'm gonna pause again. Anything? You guys are all right? All right, we're not going to add these. I want to find the least common denominator. We're not going to add them. I want to show you. Sorry, I'm trying to write and think at the same time. I want to show you one that is really different one probably you've ever seen. So I'm going to give you 3 fractions. 8 over 9x. I'm not adding them. We're just going to find the common denominator. 5 over 12x squared. And 3 over, oh, not 3, 8. Make it 1. It doesn't really matter. We're just not doing that. Okay, we're just doing find the common up. So 1 over 3x to the third. Now we're just finding the least common denominator. We're not adding them, correct? All right, so if I want to find the least common denominator, I have to think 2 ways. I got to think my numbers and then my x's. I want you to think 2 ways. So let's just do our numbers first. So I have 3, 9, and 12. Again, you might already know what the answer is, but if not, here we go. 3, 6, 9, 12. And we'll go some more because 9 is going to be 18 and doesn't match anything. So I got to keep going. So that's 15, 18. I got 18, but I don't think 12 is going to give me 18. So hold on. 12, 24, 36. So see how I'm sort of like, okay, I don't have that match yet. I don't have a match yet when it's free. 3 is a lot harder to do. 18, 19, 20, 21, 24. Oh, I got 24 and 24, but this is going to be 27. I still don't have a match in all 3 yet. And then we're going to keep going. So 24, 25, 26, 27, 30. 9 times 4 is 36. I think I just found it. I think it's 36. 30, 33, 36. Whew. 36. That's not always so obvious to find. So do your multiples. So I know I'm going to rewrite it. I'm going to save room for my x. I know I have to do an x. 36, 36, 36. Now, how do I do a variable denominator that has different exponents. Well, you have to match, you have to make them all the same by multiplying. So you take the biggest one is what one you need. I need x to the third because I can multiply. Let me change my color. Hold on. I can multiply this and get x to the third. I can multiply this and get x to the third, but I can't go backwards. I can make all of them x to the third. How do you make them x to the third? Well, you're going to multiply it by x because I need one more x. So this would be x to the third, x to the third. I didn't want to do that yet. X to the third is going to be what it is, the denominator. Now, let me go back to what I was doing. Okay, so what do I multiply x by to get x to the third? Well, I have one x. I need two more x's. That's an x squared. That would give me x to the third, which means I have to also multiply 9 by what to get 36? I'm taking this away. I need more room. Hold on. I take these away and take this away. Okay, here we go. All right, so I have 9x. This is what I have. This is what I need. What do I multiply 9 by to get 36? 9 times 4. I have one x. I need three x's, which means I'm going to multiply it by 2 more x's to get x to the third. So that means I multiply the numerator by 4x squared. What does that become? 8 times 4 is 32, and x squared. You multiply the numbers, keep the x squared. Let's look at this one. This is what I need. This is what I have. I am missing one x, and 12 I can multiply by 3 to get 36. So I'd multiply this by 3 to get 36, and I need to multiply by x. I'm missing an x. I need 3 of them. I only have 2 of them, which means I multiply this by 3x as well. Whatever I do the denominator, I do the numerator, and I will get a new denominator of 15x. And the last one, this is what I have. This is what I need. Notice I have all the x's I need. I just need to get 3 to be 36. How do I get 3 to be 36? I can multiply it by 12. I don't have to multiply any x's. I already have my 3 x's. And again, we're not adding them because we really can't add them. They're not like terms. I just want to do a really strange and different least common denominator problem with x's in the denominator or variables in the denominator. All right, that was a tough one. So any questions, ask away. You guys are very quiet.
Yes, I'm very confused.
I hear somebody.
The X's, yeah, that was confusing. I can't figure out how you made how you got the multiples of the X's. If you can do something else like
Oh, the
that.
x's. Okay, so you look at what you had. So let me go down here a second. 8 over 9x. I just want to look at the x's. Hold on. Forget the 9 for a minute. We're just gonna look at the x's. We had 8 over x. We had 5. I know we have another number too. I just want to concentrate on the x's. And we have 1 over x to the third. All right, how do you get the x's to be the same? Well, it's always, common denominator is always by multiplying. You can't divide, you can't subtract, you can't add. It has to be by multiplying. So since I have one x here and I want to get 3, I have to multiply it by 2 of them, which means it's a square. Because x times x is 2 of them, right? Because square means x times x. If you want to think of it that way, I had 1, I need to multiply by 2 of them to get 3 x's. This one, I had 2 x's. I just need 1 more. I multiply it by x. And this one, I already had it. That makes x to the third. And that makes x to the third. So what am I missing? The first one, I'm missing 2 x's. So I have to multiply it by x times x or x squared. The middle one, I had x squared. I need x to the third. I'm missing 1x, so I multiply it by x. Every common denominator is by multiplying. So if you can keep that in your head, in your mind too, it's always about multiplying, then it won't take you in the wrong direction. You might think you have to add or subtract, but not, it's all about multiplying. So if I have 1x and I want x to the third, I have to multiply it x times x to get x to the third, which means I multiplied it by x squared, 2x's. That's how we say 2x's, x times x. And that's where I got those from, the x squared, the x, and the non-x multiplying.
Okay, I see. And then you just moved what you multiplied by to the top. So that's why
Right.
32 is squared. Okay, I
Exactly,
got it.
exactly. Yeah, I know, it's hard. It really is hard. Any other questions? Very good question. Okay. I am the page. I want to do a couple more. That's the only one I want to show you. I don't think you're going to see it yet. I think you're going to see it soon. That was my cat. Somebody put a thing in chat. It's sort of funny. The cat made a chat. Okay, so let's try this one, because sometimes you have to do 3. Okay, so shoot, what number was I on? I was on 6. Yes, we're on 7. 7. So let's do no variables. Let's just do 5/8 minus a third minus a 12th. Because sometimes we have to add 3 of them or subtract. In this case, subtract 3 of them. Again, we have to come out with a common denominator. So I'm going to list all the multiples. So 8, 16. So 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. And I'm going to stop there. We can add more if we have to. I just want to see where we go. So 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. So far, nothing's matching. I keep looking at the numbers in the top to see if I can find a matching one. And I know we have to do 12 still too. All right, 9 times, what were we? 1, 2, 3. 3 times 4, 5 is 15. And then 18, 21. Notice nothing matches yet, right? 24. Oh, I got 24. Okay, so I got this. I don't know if that's the answer. We got to do 12. So 12, and it has to be 12 because 12 and 12 is 24. So my common denominator has to be 24. It's the first thing they all match. So here we go. I'll go down here. I don't like to be that far away. Let me do it over here. All right, we need 24. 24. That's my goal. I have to get all the denominators to be 24. One at a time. So this is what I need. This is what I have. What do I multiply 8 by to get 24? 8 times 3, which means I multiply my numerator by 3, which means my new numerator is 15. Second one, which is what I have. No, this is what I need. This is what I have. What do I multiply 3 by get it to get 24? If you don't not sure, figure them out. 1, 2, 3, 4, 5, 6, 7, 8. So 8. 8 times 3 is 24. That means I have to multiply the numerator by 8. So my new numerator is 8. Last one. This is what I need. This is what I have. What do I multiply 12 by to get 24? Times 2. That means I multiply the numerator by 2, which gives me 2. And I'm just going to rewrite it down here because I don't have room to do it, finish it up top. So our new fraction is 15 over 24 minus 8 over 24 minus 2 over 24. Now, what I suggest is you do one of them at a time. You could do them all at one time, but just be very careful. I'm gonna do these first. So 15 minus 8 is 7. That means I have 7 over 24 minus 2 over 24. And now I can do these two. 7 times 2, 7 minus 2 is 5 over 24. And my answer would be 5 over 24. Okay, so let's sort of kind of go in a different direction. Still the same kind of problem, but let's look at something a little different. It's still getting common denominators. So what do you do when you have something like this? 5 minus 3/5. When you have a whole number minus a fraction. Just remember that every whole number is really, the denominator is 1. So that means my common denominator has to be 5. I'm going to have to make both of them 5. So this is what I need. I have 1. That means I got to multiply this by 5 and multiply this by 5, which means my new numerator is 25. Now, this is what I need is 5, but I already have 5. So I don't have to do anything except put 3 down. And now, since they are the same denominator, I can subtract them. All right, 25 minus 3 is 22 over 5. If they ask you for a mixed number, non-mixed number, improper number answer, that is what you would put in. If they ask you for a mixed number, how many 5s are in 22? That would be 4, because 5 times 4 is 20. How many are left over? 2. 4 and 2 goes. Let's do a similar one. Let's do 6 minus y over 4. Except as a y. Don't let the y get in your way. You just do the same, you do it the same way, and I'll show you how to finish it at the end. So 6 is really over 1. So what's my common denominator going to be? Well, it's going to have to be 4. So I need 4. I have 1. That means I have to multiply the numerator and denominator by 4, and I get 24. The second fraction, I need 4. I have 4. I'm not going to do anything. I'm just going to write down y. The reason I got to show you this problem is because I got to show you how to write the answer. Now, how do you write the answer when you don't have things to combine? They're not like terms, right? So think about non-like terms. How do you write the answer? Well, we can't add them. It just stays 24 minus y. Just like that. You can't do anything. You can't simplify it. You're done. I'm going to put a be careful here. 24 minus y over 4 does not equal to. Be very, very, very careful. You're going to think, oh, I can simplify 24 and 4, right? 24 divided by 4 is 6. It is not 6 minus y. That is not the answer. You cannot simplify these because you're not by itself. You have a minus y. You can't simplify it at all because you can't divide y by 4. You leave it like that. It does not, you cannot simplify part of a fraction. It's like saying this, well, let's see. 5 plus 3 over 5. Okay, in real life, we know it's 8/5, right? But I can't do this. The answer is 3, can I? No, that's not math. We can't do that. You can't simplify part of a fraction. We have to simplify the whole thing. So this is a no-no, which means this is a no-no. You cannot do that. So this is the answer. You cannot do anything else. Done. I am gonna put a new page. I'm gonna do a different topic real quick. Okay, so finding. How do you find equivalent fractions? Which is what we're doing anyway, but in a sort of kind of different way. Okay, so we're gonna find equivalent fractions. Find an equivalent fraction. It's almost like fill in the blank. It's just like we just did by making common denominators. Sort of, kind of, making equivalent fractions, making them the same. So what do we do? Well, look at what you have, the same. I have both denominators. I have a 7, I have a 42. What can you multiply 7 by to get 42? I can multiply it by 6. So this is what I need. This is what I have, right? So that means this multiplies by 6, which means my equivalent fraction is going to be 18x. That's what goes in my blank. So you just figure out what you have to multiply. Whatever two you have the same. So let's say I have both numerators. Then I just figure out what I multiplied to go from one to the other, and that's what I multiply the other one to be. I'll do some more so you can see. Let's say I have 4 equals something over 6. So no variables. Don't forget that 4 is really over 1. So how do I go? What I have is the same. It's a denominator, not the same, but I'm going to make them the same. 1 times 6 is 6. That makes them both the same. That means I had to multiply this by 6, which means my equivalent fraction would be, my fill in the blank is 24. So figure out what you're multiplying to get the other, and that's what you're multiplying your numerator by to find the blank. (11x over 22y) is equal to 44x over blank. All right, so notice now we have numerators, right? They both have an x, so that's perfect. I don't have to multiply by x, but how do I go from 11 to 44? I had to multiply by 4, which means I got to multiply the denominator by 4 to get 44. So what is 22 times 4? That would be 88y. That's my blank. Question on that? Okay, we're going to talk about determining which fraction's smaller, which one's bigger. So insert less than or greater than to form a true statement. So we in the middle, we want to determine which one's bigger, which one's smaller. How can we do that? We can get the denominators the same. Notice everything's about the same denominator. So I have 20, I have 5. I know I can multiply by 4 to get 20, which means I multiply by 4 in my numerator. So now what I really have though is when I change it, I really have negative 16 over 20. So let me rewrite it here. So we put them together so you can see it a little bit better. They have the same denominator. So then you just compare the numerator. Which number is bigger or which number is smaller? Is negative 17 smaller than negative 16? Is negative 17 bigger than negative 17? Well, negative 17, if you think of the number line, you got negative 15, negative 16, negative 17. So 17 is smaller. So that means my inequality has to be here. So as soon as you get common denominators, all you have to compare is the numerators, and that will give you your answer. Okay, one. Let's practice these. 5, 6, and 8 over 20. 24. So which one's bigger, which one's smaller? We can get the same denominator. So 6 times 4 is 24, which means I can multiply this by 4. So I'm going to rewrite it over here. So they're together. I have 20 over 24 versus 8 over 24. Well, definitely 20 is bigger than 8. That has to be bigger. So go one more. That's not as obvious. 5 over, no, wrong one. Sorry. Oh, no, it is 5 over 6. I guess I wrote it twice. And then 7 over 21. Now, this one's different because I cannot multiply 6 by anything to get 21. So how do you do a problem like this? Well, I still can get the same denominator. So what would be the common denominator? So it's like getting common denominator. So 6, 12, 18, 24, 36. Let me stop there for a minute. 21, 42. And I actually think I have it. So what, 36 and 42. They're both can be 42. So I'm going to rewrite both of them to be 42. So 42, 42. What do I multiply 6 by to get 42? 7. So I multiply the numerator by 7 and I get 35. What do I multiply 21 by to get 42? That would be 2, which means I multiply the numerator by 2. That makes it just 14. So definitely, so the denominator is the same. I can definitely say 35 is bigger than 14. And the last thing in this section that it might ask you to do is evaluating expressions. We've done these before, but we haven't done them with fractions. One, evaluate x minus y if x is equal to 5/11 and y is equal to 4/9. So we've done these before. We just usually have like not fractions to plug in. So we're gonna substitute in. We're gonna go x is 5/11, 5/11 minus y is 4/9. So it's everything we've been doing is just in evaluate form. Now we're gonna find the common denominator. 9/11, that's a little tricky. Let's see. 9/11. 18, 27, 3 for 36, 45. If I do 11, they're all going to be like this, right? So I believe it's going to be 99. But I don't think there's any 9 that comes a double digit. 9 times 6, 54, 7, 63. Yep, it's going to be 99. So eventually we're going to get 99 when we do 11. 99. Okay, so if this is 99 and this is 99, this is what I need. This is what I have. I had to multiply by 9, which means I multiply the numerator by 9. 9 times 5 is 45. Let's look at the other fraction. This is what I need. This is what I have, which means I got to multiply it by 11. And 4 times 11 is 44. And when I put them together, I'm going to get 45 minus 44 is 1/99. Answer. And let's do one more evaluate problem. Okay, evaluate. X plus y if x is 4/5 and y is -1/3. All right, so we're going to plug in and simplify. So x is 4/5 plus y is -1/3. I'll write like that first, but then I really know it means 4/5 minus 1/3. So what's the common denominator? You can write them out, but it's going to be 15. If you're not sure, you can do the multiples like I did. So this is what I need. This is what I have. I'm going to multiply 5 by 3 to get 15, which means I multiply 4 by 3 to get 12. So 12. Now, this is what I need. This is what I have. I got to multiply 3 by 5 to get 15, which means I multiply the numerator by 5, which means my new fraction is 5. Now that they have common denominators, I can just subtract them. So my denominator is going to be 15, and 12 minus 5 is 7. Can I simplify that at all? No.
Why are we subtracting? I thought you were supposed to add it.
We're adding a negative. When you add a negative, you're only subtracting. You can leave it like add a negative if you want. I just make, when I see add a negative, I make it minus. If you do, it's the same idea. You're just adding a negative, you get the same answer. Hey, questions? Hey, we're gonna go to 4-6. Hey, while you guys are still here, I mean, while you're here, of course you're here. While we're still here talking,